All right, we're going to do two more examples. On these examples, we're still going to be taking the derivative, but this time we want to find the equation of the tangent line at a point. So for this example, we have the cube root of x plus the cube root of y to the fourth equals 2, and we want to find the equation of the tangent line at the point 1, 1. So the first thing I'm going to do is I'm going to rewrite these so that they have some nice powers going on. So I'm going to rewrite that as x to the 1/3 plus, I'm going to rewrite this as y to the 4/3 equals 2. Okay, so this power goes on top, and then the cube root, that one goes in the denominator. All right, so let's take the derivative. So the derivative of x to the 1/3, that's going to be 1/3 x to the negative 2/3 plus, this is going to be 4/3 y to the 1/3. And don't forget, whenever we take the derivative with respect to y, to change that so that it's actually the derivative with respect to x, we need to multiply by that y prime equals, and the derivative of 2 is going to give us 0. Now here's something that's going to be kind of neat. Because we want to find the slope at a particular point, we don't necessarily need to solve for y prime immediately. What we can do is that we can plug in our 1 and our 1 for our x and our y, and then solve for y prime. It's going to be a little bit easier because then we'll have numbers instead of all of these variables floating around. So I'm going to have 1/3 times 1 to the negative 2/3 plus 4/3 times 1 to the 1/3 times y prime equals 0. So what I'm going to end up with, well, 1 to any power and 1 to any power is just going to give me 1. So I'm going to end up with 1/3 plus 4/3 times y prime equals 0. Now I can solve for y prime, which will give me the slope of my tangent line. So subtract 1/3 from both sides, and we'll get 4/3 y prime equals negative 1/3. Want to get that y prime by itself, so we need to multiply both sides by 3/4. When we do that, we're going to get y prime equals negative 1/4. So that is going to be the slope of our tangent line. That means that the actual equation for a tangent line will be y minus the y coordinate of the point we were given, which is 1, equals negative 1/4 times x minus the x coordinate we were given, which was also 1. And that would be the equation for our tangent line in this case. All right, let's look at the next example here. All right, so for this example, it's a little bit grosser than the last one, but we can totally do this. Why don't you go ahead and pause the video and take a whack at it on your own, and then unpause and follow along with me and see how it turned out. Okay, great. So let's do this together. So first of all, when I look at this left-hand side, I notice that I'm going to have to use the chain rule. So I'm going to have my outside function, and then I'm going to have my inside function. So remember, when we're using the chain rule, it's going to be the derivative of the outside. So anything squared, if I take the derivative, that 2 is going to come down in front. Leave the inside alone. That's just going to be the first power, times the derivative of the inside. So when we take the derivative of x squared with respect to x, it's going to be 2x, plus the derivative of y squared with respect to y will be 2y. Remember, I took the derivative of this guy with respect to y, but I want the whole derivative to be with respect to x, so to fix that, I need to multiply it by y prime. Good, so I have the derivative of the outside times the derivative of the inside. Now we are ready to take the derivative of this guy. So notice that I'm going to have to use what rule on this guy? I'm going to have to use the product rule. So I'm going to use that guy as one function, and I'm going to use this guy as my other function. So remember, that when we're applying the product rule, it's going to be the derivative of the first thing, so 25 over 4, times the first guy left alone, y squared. Now notice that I didn't take the derivative of y squared, so I don't need to do any fixing of the units here. Plus this first guy left alone times the derivative of the second guy. So when I take the derivative of y, I need to take the derivative with respect to y. So that's going to be 2y. Now remember that this is the derivative with respect to y, so to change that so that it's the derivative with respect to x, I need to go ahead and multiply it by y prime. Great. All right, let's see. Can I clean this guy up at all? You know what? I'm not going to. Instead, what I'm going to do, since I'm finding the tangent line at the point 1, 2, I can just go ahead and plug these numbers in. Let's go ahead and do that and see how it works out for us. So we're going to have 2 times 1 squared plus 2 squared times 2 times 1 plus 2 times 2 times y prime. Leave that as y prime, remember, because that's the thing we're trying to solve for. Equals 25 over 4 times 2 squared plus 25 over 4 times 1 plus 2 times y is 2 times y prime. All right, it's actually going to work out to look really nice. So 1 plus 2 squared, that's going to give me 5, times 2, that's going to give me 10, times 2 plus 4 times y prime equals, so this is going to be 25 over 4 times 2 squared is going to be 4. Those 4's are going to cancel out, and I will be left with a 25 plus 25 over 4 times 1. Oh, you know what? I put plus. That should be times. Times 2 times 2. Those are going to cancel out, and I will have 25 again times y prime. All right, let's go ahead and distribute this 10 through. So that's going to be 20 plus 40 y prime equals 25 plus 25 y prime. Now remember, my goal is to try to get y prime by itself. So I'm going to go ahead and subtract 25 y prime from both sides. And I'm going to subtract 20 from both sides. So what that's going to give me is it's going to give me, so let's see, if I take 25 away from 40, that's going to give me 15 y prime equals 25 minus 20 is going to give me 5. Divide both sides by 15. And I'm going to get that my y prime equals 1/3. Oops, sorry, I went off page a little bit. So y prime equals 1/3. Remember, this is my slope. And this is my slope for the point 1, 2. So if I want to figure out what the equation for the tangent line is going to be, it is going to be y minus 2, the y coordinate of my point, and it's going to be equal to 1/3, my slope, times x minus my x coordinate, which is 1. And that would be